Good morning all. Today we want to solve the homework that I sent before about thermometers. Here is question number 1, page 1. So follow number of pages down. Figure 1.1 shows a liquid in glass thermometer. In the process of making thermometer, the scale divisions were spaced equally. Equally, if you remember, we said this means it has a uniform expansion. So what assumption was made about the liquid? It expands uniformly, because this is the only way that to have equal space means linear space, linear scale. So to have a linear scale, we said we need a liquid that expands uniformly. Now, so just two changes to the thermometer that would require the spacing of the scale divisions to be larger. When the spaces are larger, this means it's more sensitive. Means, he's asking you what to do to be more sensitive. So to be more sensitive, we said we have two methods. First, use narrower capillary tube, and second thing we said use larger bulb. This is the bulb. Use larger bulb with more liquid inside. Now, as a result of the change that you did in double I, as a result of this change, what other change is made to enable the thermometer to be used for the same temperature range? Okay, we said, if you remember, we said when we are using larger bulb with more liquid inside, or when we are using narrower tube, this increases the sensitivity. So this means the scale division will not reach 110, because it will reach till here, it will be the reading here, it's maybe 100 or 90. So the range has been decreased. What to do to increase the range? We can't use a thicker capillary tube because you will change this. So use longer capillary tube. Okay, now the expansion of a liquid is an example of physical property that may be used to measure the temperature. صح? State two other physical properties that may be used to measure the temperature. We can write expansion of gas or expansion of solid, or you may say the color of a metal, just like the thermometer that I have in my house, or you can say the current or voltage of thermocouple. All of these are physical properties that can be used to measure the temperature. Here we're done with question number 1. Now, question number 2. The liquids in 5 liquid in glass thermometers, A, B, C, D, and E, all of these, expands linearly. All of them have linear scale with temperature. All thermometers have been scaled in degrees Celsius. Figure 6.1 accurately responds to the scale, represents the scale of these 5 thermometers. A. Use information from the scales of thermometers. State. He just said state. We don't need to explain anything. State which one has the greatest range. Let's calculate the range for each one, then you can decide. Here the range, 250 minus negative 50. Do you see the negative here? So the range here is 300. This range is 110 negative or minus negative 10. So the range here is 120. So A is bigger. Here the range is 50. Range equal 50 directly. Here the range is 200 because 300 minus 100. Here the range is only 15. So the largest range is A. If they ask you explain, you just show the values there. Now state and explain which thermometer has the greatest sensitivity. Greatest sensitivity, we said largest degrees. Now this, look, do you see the difference from here to here? From here to here, from here to here, this is 30, this is 31, 32, 33, 34, 35. So the 1 degree is from here to here. While here, the 1 degree is tiny one, tiny, this is the 1 degree, that's it. Here it's all of this one. The 1 degree here is half of this distance. So which one has the largest sensitivity? It's E. He said state and explain. No, since the liquid has expand the most per degree. For each 1 degree, the expansion of the liquid is maximum in E. Now suggest 2 design features that would causes the liquid in glass thermometer to have a large sensitivity, as we said before, just as what we said here. We'll use narrower tube and use larger bulb with more liquid inside. So this question is repeated just to show you that yes, they repeat questions. Now the other one is question 3, page 3, sorry. Now he's saying the distance of thermometer B between the 110 and negative 10 is 18. So the distance from negative 10 to 110, all of this distance, 18 centimeter. Calculate the length of the liquid from the negative 10 to the 70, here 70. How much this distance? Let's call it X. So what do? We said before, if you remember, from here to here, the difference is 120 degrees. 110 minus negative 10, 110 degrees Celsius, give us distance 18 centimeter. Now, from here to here, how much this distance? The 80, negative 10 and 70. 70 minus 10. So 80 degrees Celsius. How much does it represent? Now you make cross multiplication. So you multiply this by this and this by this. So 120x equal 80 times 18. So x equal 80 times 18 over 120. Let me do it on my phone. Wait a second. Now 80 times 18 divided by 120. The answer is 12 centimeter. So here 12 centimeter. Now the last page, which is question number 3. In the space below, draw a label diagram of the structure of thermocouple, including the device which the reading are taken from. We said here we have the millivoltmeter, the sensitive voltmeter there. So you have to label it and we'll millivoltmeter. We said 2 wires, they have to be made from the same material. Let's say this is copper, and the third wire must be made from a different material, As we said, it could be iron, aluminum. We call this as a junction. Let's say this is hot junction. And this could be called junction. Now, a thermocouple thermometer is used to measure the temperature of the flame of a small candle. State 2 reasons why thermocouple is suitable for this application. Why it is suitable. Now, if you think with me about the answer, about the advantages of using thermocouple, we said it can measure very high and very cold temperature. Here it's the flame. Flame means it's very hot. So yes, it can measure. So the thermocouple, it can measure very hot. Wait a second, please. Okay. It can measure very hot temperatures. And second thing, as we said, it can measure the temperature that changes very quickly. So measure it responds very quickly to any rapid change in temperature. Now part B says state and explain any effect on the sensitivity of a liquid glass thermometer if we reduce the spacings, reduce the diameter. Reduce the diameter means make it narrower. So state what will happen. It will increase sensitivity. It will be more sensitive. Now he says explain why. Since the liquid will expand more per degree or for the same degree. Now if we increase the volume of the liquid, as we said, also it will be more sensitive, and the expansion برضو كمان reason more expansion per degree. That's it. Now we're done from this topic, thermometers. Now you can try to find some more questions in the past paper. Try to practice because questions are repeated, and you may send me any question that you don't know how to do it. يعطيكم العافية.